Alright, after a little technical difficulties, it looks like we are live and ready to go for our first YouTube live stream class. Today, my goal was to review a couple of the things that we've been going over in Unit 5, in particular sections 10.1 and 10.3, and then sections 10.4, which was yesterday's task. If you have any questions, please comment them in the live chat. Yes, that is me. Alright, so let's get started. The first thing I thought we might go over were a couple problems from the advanced practice of 10.1, 10.3. You will notice, and I hope you keep using these two techniques that we went over in the YouTube videos, about how we go about identifying either the prime factors of the radicand, or if we want to go about and trying to kind of find what factors might be able to be cube rooted or square rooted, etc. So let's start with the cube root of 32, x to the 6, y squared, z to the 5th. The big thing we should always do is split up the entire radicand that we're working with here. So we're going to take the cube root of 32, the cube root of x to the 6th, and the cube root of y squared, and of course the cube root of z to the 5th. Now, as we go about working through this, I'm going to do the prime factor decomposition for each of these. So let me try to, on the side here, break down 32. 32 can be broken down into 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. So let's see, that's 1, 2, 3, 4, 5 2's. Alright, so if we substitute that in, instead of saying the cube root of 32, we could say the cube root of 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Alright. And we're going to do the same thing for x to the 6, y squared, and, z to the 5th. We're going to do the same thing for them by putting them into expanded form. Cube root of 1, 2, 3, 4, 5, 6. And then I'll move down here for y and y. And then 1, 2, 3, 4, 5 for z. Now the big thing here is we need to make pairs of, well, the same value as what the index is. So here the index is 3. We need to make groups of 3 like terms. So we have 3 2's, 3 x's, and another 3 x's. We don't have 3 y's, but that's okay. So that won't break down, but we do have 3 z's right there. So if we go ahead and split up these radicands as much as we can, we have the cube root of 2 cubed, and we're just left with these plain old 2's just by themselves, but that's okay. We don't expect the square root of 32 to break down fully. Then we have the cube root of, well, there was a pair of x cubes, and then there was another group of x cubes. We said that y squared didn't break down, but we did have 3 z's, and then there were just 2 z's that were left alone. Alright, if we break this down, the cube root of 2 cubed is 2. So that goes away. The cube root of x cubed is x. The cube root of x cubed is another x, so that's x squared. And it looks like the cube root of z cubed, that just breaks down to a z. The rest of these things don't break down. 2 squared, y squared, and z squared. All of these things don't break down under cube roots, but that would be our final answer. And of course you could make this a 4 if you wanted to. But hopefully you're following along, seeing the different techniques that we're working with here. This was problem 3 from the advanced practice. Here's problem 6 from the advanced practice. Again, if you have any questions or comments, please let me know. Drop them into the live chat that we have going on right now. And let me know if there's anything in particular you want me to go over, okay? But until then, we're just going to keep working on the advanced practice and then some of the exit tickets that have been assigned. Now, when you get to radical expressions like this, especially next unit when we start incorporating when we start incorporating things like radical equations and things that need to be really simplified down, you're going to want to make sure that you first are comfortable breaking down a component of the expression. So here we're going to simplify the radical before we do anything else, right? This is a very lengthy, elaborate problem. Might as well simplify part of it before we get to the whole thing. So let's try to do some side work here, and let's simplify the cube root of 3,125 x cubed y to the fourth. Now, a lot of times students, when they're trying to break down very large numbers, they get very flustered, they start to panic, they see, oh gosh, we have this 3,125, how am I going to find perfect factors that go into this, or perfect cubes, I should say, that go into this, and they start getting nervous and they start trying to think of all these different cube numbers off the top of their head, and oftentimes they either give up on the problem or they aren't able to fully break it down as much. What I really like about the prime factor decomposition is it allows you to find prime factors fairly easily by performing some very simple multiplication, or a very simple division. For example, let's take 3,125. Okay, what prime factors could this have? It could have 2s, 3s, 5s, 7s, etc. So of those, what's an easy prime factor I can see that can divide this? Well, 5, right? It ends in a 5, so clearly it can be divisible by 5. So grab a calculator. Let's take 3,125 and let's divide it by 5. We get 625. Hey, there we go. I know that that's also divisible by 5 because it ends in a 5. And then 625 divided by 5 is 125. And that can be divisible by 5 again. 125 divided by 5 is just 25, and hey, what do you know? That breaks down. So these big numbers, it's better than trying to sit here and trying to think up using different perfect cubes that or perfect squares or whatever, and trying to think which of these is actually going to go about dividing these values, okay? So go ahead and just do the prime factor decomposition. It looks like 5 to the 5th power here. So we're taking the cube root of 5 to the 5th power, and we're also taking the cube root of x cubed and the cube root of y to the 4th. Now, as we go about doing this, I'm going to try to do this a little different where I'm not really writing things in expanded form. If you like to write things in expanded form, you are more than welcome to, okay? You probably saw me do that a couple times on the answer key. I think it's totally fine technique. Grab some scrap paper and go for it. But here I'm going to just show you a different method for working with this. Instead of having 5 5s laid out, I know that there's 5 of them, right? Instead, I'm going to say, well, let me take 3 of them for this group, and then I'll have the other 2 over here, okay? I know that there are still 5 5s, right? I just decided to put 3 in one group, 2 in the other. And then the cube root of x cubed, I know that's going to simplify. And then the cube root of y to the 4th, I'm going to put 3 y's here and 1 y here. You know things can break down if their exponent is larger than the index. So when we have y to the 4th, I know I'm going to have 3 y's in there. If I have 5 to the 5th, I know I'm going to have 3 5's in there somewhere, okay? So let's go ahead and break these down. The cube root of 5 to the 3rd is just 5, so that goes away. The cube root of x cubed is just x. The cube root of y cubed is just y. And it looks like that's pretty much it. So we have the cube root of 5 squared is 25, and y. So there we go. This is how we've gone and we've simplified, or we've broken down this radical expression. So let's clear our work here. Let's go back into the problem, and let's try to substitute in what we have. So before I forget, let me just write this down. 5xy cube root of 25y. I've made that mistake before where I've erased all the work and I forgot to write down what the problem was. All right, so we're going to sub this back in, and some people say we could probably do this a couple different ways. They're noticing that we can already simplify the 3 over the 45. You can do that. I usually just wait until the end because I'm going to have to simplify again anyway, so I figure why do double the work? So 3xy, and instead of the cube root of all of this, we're going to sub in what we simplified it to, 5xy and the cube root of 25y. And then this is going to all be over 45. So we can go ahead and we can simplify this. 3 times 5 is 15, x squared, y squared, and then we still have the cube root of 25y all over 45. A couple things I want to point out before we finish this problem. A lot of times you'll notice often in the homework that I assign or the worksheets that I make, I try to put a space right in between the last term outside of the radical and the radical sign itself. The reason is sometimes, especially Microsoft Word, if I was to be typing this, let's say, and I wanted the cube root of, let's say 25y, and I put a 3 there, students oftentimes get confused and they say, wait a minute, is this y cubed or is this the cube root of something, right? Where does the 3 go? Is it an exponent or is it an index? So that's oftentimes why I try to put a little space there. You'll also notice in my writing, and I recommend that you do this, you try to manually have a little bit of a space in between those values so you yourself don't get confused with what's the index and what's the exponent, okay? And it's easier for me to kind of read your writing, and if you can try to work on that a little bit, just because I've seen a lot of students that mean something as the index, and then as they're going through a very elaborate problem, they forget and they think it's an exponent or vice versa. All right, and then the last thing we have to do when we are going about and simplifying this problem is we need to simplify the numbers. So here's a question for you. Can we simplify 25 over 45? Or should we simplify 15 over 45? Which of these values should we break down? The 15 over 45 or the 25 over 45? Or should we combine the 15 and the 25? Take a minute, think about this, and we'll come right back. Sorry, I had a coffee break right there. All right. Now, hopefully you had some time to think about this, and hopefully you're recognizing this type of problem and what we talked about in our previous video. But we actually can't simplify 25 over 45 for a number of reasons. One, the short example is because 25 is under the radical sign. It's the radicand, okay? The other reason is, and this is something that a lot of students trip up with, we want to make sure that we know that the cube root of 25 is not the number 25, right? People see, oh, there's a 25 and a 45, I can divide both of these by 5. That's not the case. This is not the number 25. This is the cube root of 25. This is a decimal that goes on forever and ever and ever and ever and never repeats a pattern. That doesn't have anything in common with 45. So we can't simplify within the stuff outside of the radical and stuff inside the radical, okay? They're really kind of separated. So the things that we can simplify are things on the outside, the 15 over the 45. So let's go ahead and do that. We're going to end up with, let's see, 15 divided by 5 is, oh, actually, I'm sorry, 15 goes into 45. So we end up with x squared, y squared, the cube root of 25y, all over, let's see, 15 goes into 45 3 times. And that should be our final answer. Is there any confusion on this problem? If so, let me know in the live chat, and I'm happy to help out. I'm going to be posting this video, obviously, once we're done, so you can go back and take a look at. I'm also going to be doing a second live stream at 2 o'clock for 4th hour, but everyone, of course, is welcome to attend that, whatever hour that you're in. As we go through these problems, please let me know. Pause me if you need any assistance. You know, shoot me a message in the live chat and let me know. Hey, how did you get it? How did you get this part? Can you re-explain that? Can you go a little slower? Let me know. We'll go from there. All right, let's switch up sections and let's try section 10.4 where we have to go and add and subtract radicals. Now, when we go about adding and subtracting radicals, the thing that we need to have are what we call like radicals. And like radicals, let's remind ourselves really quick, like radicals. Like radicals are radical expressions that have the same index and the same radicand. Okay, same index and same radicand. So right away, most students would say, well, look right there. Those aren't the same radicands, right? They're the same index. Our index is a 2 for all of these because these are all square roots. But remember, we don't write the 2 there. So we have the same index, but we don't have the same radicands. Now remember, we should always, always, always simplify everything down completely. As we go about simplifying everything down completely, we can see if in fact these things simplify to having like radicands. So we're going to go ahead and do this. I'm going to do this in a couple different colors. So let me see. I'll use red for one. And then I recommend you do this as well. Try to use colors. Try to section off your work. Get some scrap paper. Don't do all of this all at once, okay? Because when it comes to problems like this, really the biggest way that people either make mistakes or succeed is based on their organization, right? A lot of these problems, they're very simple to do when we work them out together. Students often are like, oh, okay, that was pretty easy. But the thing that we really need to get down is how we organize our work. So you'll oftentimes see me do a lot of scrap work to the side, things in color, before we go back and complete the problem. So I'm going to go about and do the square root of 24a cubed in green. I'm going to do that to the side here. All right, the square root of 24a cubed. You know what, I haven't used the first method we went over for simplifying radicals, so why don't I try that one as opposed to the prime factor decomposition. Let's see, 24. That has factors of 4 and 6. And then a cubed will simplify separately. So let's see, that's the square root of 4, the square root of 6, square root of a squared, and the square root of a. So we end up with a 2, and an a. That's how those simplify down. And then we have root 6a. Okay, so we simplified this down to have a radicand of 6a. Let's see if we can do that for the other ones. Let me try to move some of my work over here, and let's do the square root of 54, a to the 5th, b squared. Now 54, let's see, I think that has a factor of 9 and 6, yeah. So let's do the square root of 9, the square root of 6, a to the 5th, and let's do the square root of b squared. And, well, let's remember, so that's a 3, that's root 6. A to the 5th, that has factors. I could break that up into a to the 4th and a, and b squared just simplifies to a b. So we know how those simplify. So we end up with 3, a to the 4th, the square root of a to the 4th. Hopefully you've noticed the pattern here. We're going to go over that more on Friday in section 10.2. And why there is this pattern, but when you're taking the square root of something, it's kind of like just dividing it by 2, right? Because we're taking something and we're saying how many groups of 2 are there, how many pairs of 2 things can this be broken down into. So a to the 4th becomes a squared. We have that b on the outside, and everything under the radical was, hey, 6a again. So it looks like we are going to get common radicals here, or I'm sorry, like radicands, because as we go about simplifying them, what we're left with is going to be the same radicand for everything. Now let me change up into red here, and let me try to break down the square root of 150 and a. Now the square root of 150, let's see, 5 goes into 150 and 30. Let's see. I'm trying to think of what, well, 25. So let's see, 150 and 25, that should be 6. Yep. 150 can be broken down into, let me move my work here, the square root of 25 and the square root of 6, the square root of a. So square root of 25 simplifies to a 5, and then 6 and a combined together. So again, we have another like radicand. We have the square root of 6a. So in fact, this problem can be combined together. Don't go and just, all of a sudden say, oh, they're not like, they can't combine together. Definitely have to check. You have to make sure that the things, when simplified, can in fact be combined, or if they can't be combined. So let's go ahead and let's try to see what we have here. Let me clear some space. Actually, let me go to the next page. All right, we had, I think it was 3 over 2 AB, 3 over 2 AB, and instead of writing the square root of 24a cubed, we're going to write 2a root 6a. Let me try that in green here. 2a root 6a. And then we had to add 4/3. So I'm bouncing back and forth here. I probably should have written this down on a separate sheet of paper. And instead of the square root of 54, a to the 5th, b squared, we're going to put in 3a squared b root 6a. 3a squared b root 6a. And then the last component was we had to subtract a squared b, and we were going to multiply that by, instead of the square root of 150a, we're going to have 5 and the square root of 6a. So 5 root 6a. And there we go. This is going to be much easier to simplify down. So let's go ahead and let's take it one part at a time. So let's just multiply these things together. So we have 3/2 times 2. Well, that's going to just be a 3. We have an a times an a, so that's a squared. B is just kind of by itself there. And of course we have the 6a. Now let's go about multiplying these. 4/3 times 3 is just 4. Then we have the a squared and b. Those are left there, and the 6 root 6a. And then minus, well, nothing really simplifies down here, so we're just left with 5a squared b root 6a. All right, so we've gone through, we've simplified down the radicals completely, and now we have this expression. Before we go and combine, we have to do a couple checks, right? Make sure, are these like radicands or like radicals? Yeah, we have the square root of 6a, square root of 6a, square root of 6a. So everything, all of the radicals are like. So we can go ahead and combine those. But we also have to make sure that the things you're going to add together, because when you add or subtract like radicals, you're really adding or subtracting the numbers and the values out front, right? I call them the kind of pseudo coefficients of the radicals. So these are the things that you're adding together. You have to make sure you can actually go about adding those. Make sure that they are in fact like terms. So in this case, are they like terms? Well, they all have the same variables and the same exponents on the variables, so yeah, we actually can go ahead and add and subtract these together. A couple of the problems I was a bit tricky on them because some of them you actually couldn't go about simplifying. So let's see here, 4 and 3 is 7. 7 minus 5 is 2, a squared b, and the square root of 6a. That's a terrible b. but you get the point. All right, so this is going to be the final answer. This is going to be how it breaks down. You'll notice this problem wasn't really that bad. I mean, it's a bit tedious, but really, each of these were fairly simple to break down. We just have to make sure we're taking steps to ensure our work is organized and we know what values are what. I would recommend doing this technique where we simplify our radicals to the side. We use color coding, things like that. Because if we don't, if you try to string all of this as one long expression, right, try to fit everything together at once, it's going to be very messy and it's going to be very complicated to see. You're going to need quite a lot of room. So I think it's good to have things to the side and use color coding as best you can. Because once you have everything and you plug stuff in, it's fairly simple to simplify down. All right, now let's try a practice from the exit ticket. This is one that people were having some trouble with. Sometimes people looked at this and said right away, oh, we can't simplify this down. They are not like radicals. The radicands are different, so we can't simplify this. Well, keep in mind we need to first, or we can't combine these, so keep in mind that we first need to simplify them to see if we can't combine them. Because these radicands can break down. And I don't know if they break down into the same thing or different things, so we have to check. So I'll do some work in separate colors. I'll do all of this in red, and I'll do all of this in blue. And let's see where we go. So first up, we have the cube root of 256, x to the 6, y. So we need to take the cube root of 256. We need to take the cube root of x to the 6, and we need to take the cube root of y. Now 256, I don't know of perfect cubed factors that go into that, so I'm going to do my prime factor decomposition. Let's take 256 and let's divide it by 2. So 256 divided by 2 is going to be 128. I still don't know factors of that, so let me just divide it by 2 again, because I know 2 goes into it. So when I divide it by 2, we end up with 64. Well, now I start having ideas about how this is going to be broken down. So 64 can be broken down into 8 times 8, which can be 2 and 4 and 2 and 2, and 8 can be 2 and 4 and 2 and 2. All right. One of the things that I like to do is circle all of the prime factors, just because sometimes it gets kind of messy, as you can see here, and I want to make sure I just have everything. So 256 is 2 times 2 times 2 times 2 times 2 times 2 times 2. Let's see, that's 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th power should give me 256. Wait, did I miss one? Oh, look, I missed one right there. So 2 to the 8th power should give me 256. And checking on the calculator, it does. So let's see here. Instead of the cube root of 256, we're going to take the cube root of 2 to the 8th power. And then we still have the cube root of x to the 6 and the cube root of y. So let's go ahead and let's split up this 2 to the 8th power. We're going to take the cube root, instead of 2 to the 8th, why don't we put, well, we have a pair of 3's in there, or a group of 3's, I should say, and then we have another group of 3's, that makes 6, and then for the last 2, we'll just leave here. So make sure you're understanding how I went and broke this down. Ask me a question, let me know if you're confused in live chat. We have basically 8 2's to group together. So I put 3 in one group, 3 in another group, so that made 6. And then the remaining 2 for the 8, I just left over into the other radical. So hopefully you're understanding how we broke this down. If not, let me know, and I'll go back over that, or I'll show you an expanded form. And then we have, oh, I'm running out of room here, so let me erase these prime factors. Now let's break down the x to the 6th. We can use our shortcut that we talked about by just dividing the exponent by the index, but I'll hold off on that a little more until we get to Friday's lesson. Let's split up the cube root of x to the 6th into the cube root of x cubed and then the cube root of x cubed again. So I have 6 x's, and I decided to put 3 in one group, 3 in the other group. And then I just have 1 y, so that I know is not going to simplify down. So let's try to see what we end up with here. The cube root of 2 cubed is 2. Cube root of 2 cubed is 2. Cube root of x cubed is x. Cube root of x cubed is just x. And the things that don't simplify down are, let's see, the cube root of 2 squared, which is 4, and then the y by itself. These don't actually go and break down, which is fine. We don't expect them to. So the final answer for this first radical is going to be 4x squared and the cube root of 4y. So that's the first thing that we went and simplified down. So let me go ahead and write that in its place here. We're working with the cube root of 4x squared. Oops, I messed that up. We're working with 4x squared and the cube root of 4y. Now let's go and simplify the other radical down. So I'm going to clear my work here. Again, don't worry, I'm going to be posting this video later so you can look back if you had any questions on this. And again, if you have any future questions, feel free to contact me, shoot me an email, or let me know in the second live stream that we're going to be doing later today, starting at 2 o'clock. Let me swap colors, and here we go. Let's take the cube root of 108 x cubed y. So again, I don't know off the top of my head what are some factors of 108, what are some cubed factors of 108, so I'm just going to start simplifying these down. Let's take 108, and let's divide that by 2, and we get 54. And then if we divide 54 by 2, we should end up with a 27. And then that can break down into 3 and 9, which can be 3 and 3. So 2 times 2 times 3 times 3 times 3. So let's reorganize these. We have the cube root of 108. We have the cube root of x cubed. And we have the cube root of y. Now, instead of 108, I have the cube root of 2 squared and 3 cubed. 3 cubed is 27, 2 squared is 4, 27 and 4 make 108. And then the cube root of x cubed, I won't simplify that just yet, and the cube root of y. So you're seeing how I'm going about splitting up the cube root of 108. I'm just using its prime factors here. And again, I'm just holding off to simplify anything until the last step here. So the 2's aren't going to simplify down because I only have 2 of them. So that's not going to break down. However, I'm expecting, because I have 3 3's here, those can go about and simplify. So let's go and check our work. The cube root of 3 cubed is just 3, so that simplifies. The cube root of x cubed is just x, so that simplifies down. And then we're left with cube root of 2 squared. Now that doesn't simplify. So then 2 squared is a 4. And then the cube root of y by itself, that doesn't simplify. So we're left with the cube root of 4y. And hey, what do you know? We have a like radical here. So let's go ahead and let's plug our answer in. We had the minus 7x before, and we have to multiply this now by what we got. 3x and the cube root of 4y. Now let me clear some workspace. And again, if you have any questions, let me know in the live chat. Let me know if I'm going too fast or anything, or if you have any questions. I'm guessing most people are like, still in bed, probably going to tune into the 2 o'clock live stream. All right, let's go about simplifying this a little bit. let's perform that multiplication on the second radicand first. So we get minus 21 x squared and the cube root of 4y. So we just went and multiplied those together to get 21x squared. Now we have to check to see if we can actually combine these together, if we can subtract them. Well, they have the same radicands and the same indices, so these are both like radicals. So right away we're thinking, yeah, we can go about combining these together, but we have to see if the numbers or the values on the outside can actually combine. Let's see, a negative 21x squared and a 4x squared. Those are both like terms. They have the same value, the same variables, and the same exponents on the variables, so yeah, let's go ahead and combine them together. 4x squared minus 21x squared. Now keep in mind, signs are important here. So as we go about subtracting this, don't say we get positive 17. A lot of times people see, okay, 21 and 4 and I'm subtracting, they go with 17. Keep in mind, remember, our signs are important. We end up with negative 17 x squared. And then don't forget, we have the cube root of 4y. Again, I'm trying to put a little space in between so we can separate the x squared from the cube root. But here we go. Here is our final solution. We have gone through and we've simplified each of the radicals down completely, and then we use those values to actually go ahead and combine this. So this is kind of how I'm expecting you to have worked on the exit ticket. This is the second one of the problems for 10.4. Make sure you're still solving problem 1 and editing that if you need. And if you have any questions, let me know. So I'm not really hearing anything in the live chat, no real questions that people are sending over to me, so I might end this live stream a little early. If you have any other questions, feel free to get in contact with me. We're going to do another live stream at 2 o'clock today on March 18th, and then I have office hours after that, so I'm going to be doing individual meetings with people. Make sure you're checking out linfordmath.weebly.com. That is linfordmath.weebly.com. So besides just getting all of your homework and assignments on there and working through the different section modules, I also have a contact tab up there where you can go and check my office hours for the next 2 months, see my breakdown calendar, and you can actually go and schedule meetings with me via Google Calendar. So there's a link in there for how to go about scheduling an office hours meeting with me. So feel free to use that, or if you're having any difficulty, just shoot me an email to let me know. Reminder that my email is Linford, that's KLINFORD at wccnet.edu. All right, I'm going to end this live stream a little bit early and allow people opportunity to continue working through some of these problems. If you have any questions, shoot me an email. And then, reminder, at 2 o'clock is going to be the next live stream. Until then, take care.